Continuing our discussion on iterations, aka also known as loops, and specifically we're talking about the for loop here. Recap on the flowchart. As described previously, code blocks go into executing code blocks, then you come here and you'll have some for loop, which is some variable equals some vector. And as long as you're going down that vector, you will iterate through this code block, and when you are done with that variable going down that vector, then you exit the loop, and then you continue on executing some code block down here. So that is the general form of the for loop. Now let's see how this manifests itself in a couple of problems. Now, there are two different varieties or two different classifications that I want to talk about when doing the for loop. One is doing a problem through a method called direct access, and the other is a method called indexing. All right, I'm going to cover each of those, and I'm going to show you the same problem done for both. Okay? And so the first problem I want to do is simply have it count through a vector of numbers and display them to the screen. So I'm going to write a couple of scripts here. So the first script is I'm going to say for, keep in mind it's for some variable, I'll write this out this time, equals some vector. Okay, so that's the way it looks in general. Some variable equals some vector, and in fact, if I wanted to go even further, you execute some code block inside of here, some code block, and then you end. And that's what this diagram over here looks like in code. So for some variable equals some vector, execute the code block, and then you end. In fact, let me put this over here, I guess, in our little notes section. For some variable equals some vector, execute some code block, some block of code, and then you end. All right, cool. Now, let's show it in action here. I'm going to do for some variable, I'm going to call it my variable x, equals some vector 1, 2, 3, 4, 5. Okay? And then what I want to do is I want to display x. Display simply is going to write it down into the command window. And then I go end. So there you go. That's a for loop. Now, what happens when I execute this? So let's say if I go and take a look down in the command window and see what's happening. Right. Also, let's go over here to our block diagram and see what happens over there. So I've got for, and I've got I've got variable x equals the vector 1, 2, 3, 4, 5. Okay. Now, when I come through and hit this for loop, x equals the first value, so x equals 1. So here, over here, x is going to equal 1 the first time through. Then I do my code block, which in this case my code block is display x. That's what this would be. So I do a display x. Right? So now I display the value of x. Well, at that time, the first time through, x equals 1. So inside the command window, the value 1 gets displayed. Okay? Then I come back up because I've ended. I've done all the things in my code block. I come back up. Now x equals the next value in the loop. So at first it equaled the first value. Now x now equals the second value, which is 2. So I execute this code block, which is display. So 2 gets displayed to the screen. Now I'm done with the code block. I go back up. X equals the next value, which is 3. So now x equals 3. I do what's in the code block, which is display x, so now 3 gets displayed to the screen. I finish that, I loop back up. Now x equals the next value, which is 4. Okay, so now x equals 4. I go to the code block, which is display. 4 gets displayed to the screen. I go back up, x equals the next value, which is 5. So now x equals 5. I do the code block, which is display x, so I display 5. And then I come back in. I'm done with the vector, so I hit done, and I would execute the next following code, but there is nothing in this particular example. So that's how this works. Okay, let's do another example. Let's say instead of, and this time I'm just going to go through the code here and not through the block diagram. So let's say if instead of 1, 2, 3, 4, 5, x equals, clear my command window, let's say the vector is 23, I don't know, 42, 16, 8, and 12. Say it's that. Okay. So now I come into my loop here. X equals the first value, 23. So I do the code block display, so 23 gets displayed. I come back up. I loop back up here until I get to the end of my vector. I loop back up. X now equals, so it was 23. I loop back up the second time. Now it's the next value, which is 42. And I display 42. I loop back up. X becomes the next value, which is 16. I do my code block here. X equals 16, so I display 16. I go back up. X equals the next value, which is 8. I do what's in my code block here, which is display X, so it is the value 8. I go back up. X equals the next value, which is 12. I do what's in my code block here, which is display X, which is now 12. I display 12. I go back up. I've hit the end of my vector, so I stop execution and come out of the loop and exit the loop. Okay? So that is how it works in Matlab, or just about in any language. But that's how the for loop is implemented in Matlab. If you understand that basic functionality, then you're well on your way to understanding how for loops operate. Okay, now I'm going to show you, let's continue this thought, and then I'll get to the indexing method. There's nothing different in the mechanics between the direct access and the indexing. It's just that the indexing does things a little bit differently when it comes to vectors. So we'll look at that in a second. Okay, so now let's say, once again, it is some variable equals some vector, right? So let's now, instead of doing that, the direct entry way of a vector, let's say if it was 1:3. Well, 1:3 is just a different way of writing the vector 1, 2, 3. So this shouldn't really cause you any problems. This is just the vector 1, 2, 3. So therefore, when I run this loop, what will happen is x will equal 1 the first time, and so 1 will be printed. X will equal 2 the next time through, and x will equal 3 the following time through, and then you've reached the end of the vector, and then you exit. It'd be the same thing if instead of 1:3, let's say it's 1: let's say if it's start step stop, it's 1:2:10. Okay, so in that case, if it's 1:2:10, then you've got the vector 1, 3, 5, 7, 9. Okay, well then, first time through the loop, display is going to display the first thing in the vector, which is 1. Next time through the loop, it's going to display the next time in the vector, which is 3. The next time through the loop, it displays the next thing in the vector, which is 5. The next time through the loop, it displays the next thing in the vector, which is 7. And the next time through the iteration, it displays the next thing in the vector, which is 9. And then it's reached the end, so it ends. Okay? Let's keep going. Any vector can go in there. I can use linspace if I wanted to create a vector. Any vector can go in there. If I did, let's say if I did 10 colon -2 start step stop 0, then I get the vector. Then I get the vector 10, 8, 6, 4, 2, 0. So what's going to be printed out? Well, first time through, x is going to be 10. The next time through, it will be 8. The next time through, it will be 6. The next time through 4. The next time through 2. And the next time through the loop, it will be 0. Then it ends and exits out. This is, and so it also works. Once again, let's say if I did not put the variable, the vector directly there, but above here I said a equals the vector, I don't know, -99, 16, 0, 89, and 8. Okay? And I say x equals a. Well, that's this a is now defined as this vector. So now we do the same thing. First time through, x is going to equal the first value in a, which is -99, and that gets displayed. The next time through, x is going to equal the next value in a, which is 16. That gets displayed. The next time through, it's going to equal the next value in a, which is 0. That gets displayed. The next time through, it's going to equal the next value in a, which is 89. The next time through, it's going to equal the next value in a, which is 8. And then it's reached the end of a, so therefore the loop ends. That's it. That is how you do for loops. That's the direct access method. I'm going to show you now the indexing method using this same example here, and you'll see what I mean by it's a little bit different. So let's keep the same basic code. A equals 99, 16, 0, 89, and 8. Now look at the subtle differences here. I'm going to say 4x equals 1 colon to the length of a. Well, a has 1, 2, 3, 4, 5 things in it, so that's just like saying 1 colon 5, which is just like saying the vector 1, 2, 3, 4, and 5. Okay. Write that a little clearer here. So this is just like saying the vector 1, 2, 3, 4, and 5. Okay. All right. So x equals 1 colon the length of a. This is a vector. It is the vector 1, 2, 3, 4, and 5. Right? If you notice, these are the indexes of these items that are inside the a vector. So what I've done is x doesn't equal the direct access. It's not going to equal directly the values in a, but it's going to equal the indexes of the value of a. And this is how I use that. So instead of displaying x directly, I'm going to display a indexed at x. Right? So the difference with the indexing method is that my loop variable is not going to be equal to the direct values in the vector. It's going to be equal to the indexes in the vector, and then I have to access the values via indexing inside of the loop, of the code block inside the loop. So just to bring the point on home, let's say this is my command window, and let's go through this. Okay, so I come in and a equals 99, 16, 0, 89, and 8. So that's what a equals. Then I start executing my for loop. X equals 1 colon the length of a. Well, the length of a is 5, so therefore x equals what is going to be equal to the vector 1, 2, 3, 4, 5. So I'm going to go through the vector 1, 2, 3, 4, 5. So the first time through, x equals 1. And I'm going to display a indexed at 1, and the a indexed at 1 is the value -99. Next time through, x is going to be 2. I'm going to display a indexed at 2, which is the value 16. The next time through, x is going to be 3. I'm going to display the value of a indexed at 3, which is 0. The next time through, x is equal to 4. I'm going to display A indexed at 4, which is 89. The next time through, x is equal to 5. I'm going to display A indexed at 5, which is 8. Which you can see I get the same thing that I get when I did it the direct access way. Okay? It's just a different style of doing things. And we're going to look at the next few examples that I'm going to do. I'm going to show you to you in both ways so that you continue to understand that it's a different way of doing things. There will be times when one way is preferred over the other, but for these examples, I'm going to present them to you both ways. Okay, so for the next example, erase this. For the next example, I'm going to get in a vector A, and we can just use the same vector we just used, negative 99, 16, 0, 99, and 8. And I'm going to give a scalar value B, let's just say 10, and then I'm going to make C equal to an empty vector, because here's what I'm going to do. I'm going to loop through, I'm going to use my for loop to iterate through or loop through the vector A. And I'm going to make a new vector C. I'm going to build up a new vector C. It's going to start off empty. I'm going to fill it with things that are in A and greater than 10. So I'm going to loop through A, and every value that's greater than 10, I'm going to put in a new vector C. And this is going to use a lot of the concepts that we've been building thus far. So let's go ahead and do this. 4, let's call it x, equals A. So x is now going to iterate down the vector A. Okay? Well, I want to test each value, and if that value is greater than 10, I'm going to put it into C. I'm going to concatenate it onto C. So I'm using a lot of the terminology we've been building thus far. Well, if I want to make a decision, I'll use the if statement. So inside the for loop, I'm going to make an if statement. If x is greater than b, right, then the value of vector C is going to be a concatenation of the old value of C with the value of x concatenated onto it. And this is how we're going to build up the vector C. Then I will end my if statement because I've done what I needed to do. And I will end my for statement because this is how it's going to iterate through. So for every value inside of A, I'm going to check to see if it's greater than B. And if it is, I put it in using this way here. I'm going to put it in to the vector C. Okay? So if I run this, and let's do a simulation of the command window. We'll look at this in actual runtime when I do the Matlab portion of this. When I run this, I'm going to, so I come down, I set A equal to this vector here, B is equal to 10, and C is an empty vector. For x equals A, so x is going to start off being 99, and then it's going to loop through all successive values in A. I check. So the first time through, A is negative 99. I check. Is negative 99 greater than B, and B is 10? Well, the answer is no, so I don't do this. So then I loop back through. So I've done nothing thus far. I loop back through. X now equals 16, the next value in A. Well, then I check. If x, which is 16, is it greater than b, which is 10? Is 16 greater than b? Yes, that logical statement is true, so I execute what's inside the if statement. So c, which is the empty vector, the new value of c, equals the concatenation, sticking together, the empty vector, and I'm going to stick the value of x onto the empty vector. So now c at this point in time is going to be the vector with 16 in it. It went from the empty vector to the vector with 16 in it. Now I end that if statement, go back through the loop. A now equals the next value, x now equals the next value in A. X now equals 0. Is 0 greater than 10? No, it's not. So I skip this, go again. Now x equals the next value in A, which is 99. If 99 is greater than 10, 99 is greater than 10. So now I get C equals the old value of C, which was the vector 16, concatenated with x, which is now 99. And so that gives me the new vector 1699. Whoops, 1699. Okay? And so this is how you build up C with the results that I want. And we see this technique over and over again. So that's why I'm being very deliberate here. Okay, so now C equals 16, the vector 1699. I end that, I go back up. X now equals the next value in A, which is 8. Is 8 greater than 10? No, it's not, so I skip that. And now I go back up. Well, I reached the end of my vector, so I exit now, and I'm done. So I test, I go back down, I'm done. All right, so now, and I did not put this. I guess I need to put this here. Let's do a DISP, a display C. So now the block of code after my for loop, I'm going to display C. And so what gets printed out down here in the command window is vector C, which is 1699. If you type that in Matlab, that's what you'll get. Okay. Well, now let's see this same script executed over here with the indexing method. So I do A equals -99, 16, 0, 99, and 8. B equals 10. C equals the empty vector. 4, x, now x is not going to equal A, x is going to equal the indexes in A. So I get that by saying the indexes in A are going to go from 1 to the length of A. And so I use the length of A. Okay? And so this is going to be the vector, once again, 1, 2, 3, 4, 5. So now I'm going to check if, I can't check if x is greater than b. I need to check the values here. So I need to use x to index A. So I say if A indexed at x is greater than b, then C is going to equal concatenation of C with A indexed at x. And then you end here, and then this time I'll remember to put the display C in here. Okay, after I finish my loop, once again, I'll go through this. Okay, so A equals this vector. Next line of code, B equals 10. Next line of code, C is the empty vector. 4x equals 1 to the length of A, which sets up the vector 1, 2, 3, 4, 5, which are the indices of vector A. Once again, 1, 2, 3, 4, 5. Been doing that since day one. Okay, now I go in here and I say, well, the first value of x is going to be 1. So if A indexed at 1 is greater than B, well, -99 is not greater than B. So I skip over this and I loop back through. So I come back through here. Next, x is going to be 2. So this says if A indexed at 2, A indexed at 2 is 16. Is 16 greater than B, and B is 10? So is 16 greater than B? Yes, it is. So now C now equals the empty vector, which has nothing in there, concatenated with A indexed at 2, which is the value 16. So now C equals 16, the vector 16. It's a vector with one thing in it, which we call a scalar. Okay. All right. So this is the present value of C, 16. So now you go back up. You're not finished with going through A yet. So go back up. Now x is this next value, which is 3. So x is now equal to 3. You say, is A indexed at 3 greater than B? Well, A indexed at 3 is 0. Is 0 greater than 10? No. So you skip this. Go back up. Now x is equal to 4. So you ask yourself, is A indexed at 4, which is 99, is 99 greater than B? The answer is yes. So you come back in here. So now C equals, keep in mind C was 16. So now you have C equals the concatenation of 16 concatenated with A indexed at 4. A indexed at 4 is 99, so you have 16 concatenated with 99, and once again you have C equal to the vector 1699. Okay? So that's what C equals now. And so this is all gone there. So now you come back through, X is now equal to 5. You ask yourself, is A indexed at 5, which is the value 8, is that greater than B, which is 10? Is A greater than B? No, so you skip that. You're done with your loop because you've gone through every value of X, every value in this vector. X is equal to every value in this vector. So you're done with your loop. So you exit that and you come down here and you display C, which is 16 and 99. Okay? So those are two examples, the counting example and then this with sort of the cutoff comparison example. These are two examples of both the direct access method and the indexing styles of how you use the for loop. Okay, this and the next few videos are going to be examples of what I just covered on the board, implementing the for iteration statements, the for loops in various examples. I'm going to go through 4 examples, and each example I'm going to do using the direct access style and the indexing style. So I'm going to try to capture a lot here on the screen. So if I confuse, I hope not to confuse you by readjusting windows and doing things, but I really want to show you what's going on, not just with the code in the editor, but also with the variables in the workspace. I'm going to use the debugging methods with setting breakpoints so that you can see the iterations happening. And I also want you to see what's going on in the command window. So there's going to be a lot going on. I'm going to use the statements clear all and clear a lot to keep the command window and the workspace as clear as possible, so that we can see the variables developing and the values changing as we go through the iterations. So the first thing I want to do is I want to let's just do some basic counting here. So we're going to do some basic counting, and let's use the direct access method or style first. Make this a little bit bigger so we have a little bit more room. Okay, and so just as I did on the board, I'm going to come through and say X for X equals the variable, the vector 1, 2, 3, 4, 5. And then I'm going to display X and I'm going to end. Okay, so that's a very basic script for using a for loop. I'm going to save it and run it. It's going to ask me for a name, so I'll say counting. I'll do it this way. And all right. And so you see things happening this way. So the display is going to give me it vertically. So that might be a little different than what I did in the off the board, but you get the general idea here. Okay, so that's when it runs instantly. Let's take it and slow it down a bit and put some breakpoints in there. These are breakpoints, so as I execute the code, it's going to stop at these breakpoints. Also, what I want to do, this is, once again, not a part of the code, not a part of using for loops, but this is just a part of Matlab that I want to clear and give me a clean slate every time I run this. So let me clean slate. So this is a way for me to clear the workspace and clear the command windows every time I run this. So if I ran this again, what would happen is everything that I've done prior to disappears, and that's good. Okay. All right. So now, as you can see, I executed the program by hitting the green arrow up here. And the program stopped running at line 6 because I have a breakpoint there. Okay. And so by hitting F10, I'll be able to step through this program and we can watch what's happening over in the command window, down in the command window and over in the workspace. Let me tighten this up so I try to get all of this into one tight view on the screen. Okay, so as I hit F10, so right now we're at the for loop and it's going to set up. So when I execute that line 10, okay, had to make some changes to my work environment here. So if you're confused, there was a jump in an edit in the video. Had to make a change because the F10 key that you use to step through your code when you set your brakes over here is also the F10 key that stops the recording in my screen recording software. So I had to stop and make some changes here. So as you can see, I've taken these commands, which are the commands that deal with breakpoints, that usually are, if I make this bigger, that usually are way over here on your toolbar. I had to move them all the way over here in order to be able to deal with this. So a little explanation as to why there's a big jump in the video just then. Okay, so back to Matlab. So we've got this set up. Got our windows cleared. This is a clean the slate up here. Got this set up. So this is our for loop. And so for some variable is equal to some vector. And so this variable is going to go through each value of this vector. And we're going to display that value each time we go through this loop, just as we did on the board. So I have a breakpoint set so that we can see what's happening in the workspace and what's happening in the command window while this is going on. Okay, so I've got this saved already, so I'm going to execute it. It goes down here and gets to line 6. Okay, and so as I step through, which is this button here, I step through, I click it again. Now we've executed line 6 and we're getting ready to execute line 7. So now x equals the value 1, and that makes sense because x is now equal to the first value in our vector. Now we're getting ready to execute line 7, which now you see actually displays the value of x, which is 1. All right, so we're at the end. We execute again. We step through again. We go back up to the top of our loop. And now, as you can see, x equals the value 2. All right, we step again. We display that value 2. We step again. We go back up to the top of the loop. Now x equals the value 3. We step again. We display that value 3. We go back up to the top of the loop. X now equals the value 4. Now we step through. We display that value 4. We go back up to the top of the loop. Now x equals 5. Step again. Now we display the value 5. And now we've exited the loop, and so we go on. This little green arrow is sort of helpful here. It says now we go on with whatever code would follow. No code follows here. So now our program, our script ends. So that's a demonstration of x and x going through the values in this vector for the for loop. As I said, let's change this up a little bit. Let's say the vector is now vector 23, 42, 16, 8, and 12. That way the numbers aren't the same as the index, so it gives a little more clarity. And let's run this again. Remember, when I run it, this clear all on this CLC. Clear all will clear everything from the workspace, and CLC will clear the command window here. So when I do that, we start off with a blank slate. Well, it actually ran the program because I didn't have my breakpoints in here. So let's put the breakpoints back in here. Run it. Now we start here, top of the loop again. X is going to equal each successive value in this vector. So as I step through, x for the first time through, x equals 23. I step again, we displayed that 23 here in the code block on line 7. Step again, x now equals 42, which is the next value in this vector. And we click again, we step through again, we display the value 42. Click again, x now equals 16. Step again, now we display the value 16. Step, x now equals 8. Now we display the value 8. Step again, x now equals 12. We display the value 12. Now we go on because we've hit the end of that vector. X has exhausted all the possible values. We go on, and then our script ends. So let's go again. So that's another example of going through a vector. Another example, let's just do 1:3. Oops. Let's do, screen just refreshed, 1:3. Okay, we do that. We're at, so let's set our breakpoints again and run this. Okay, so everything's cleared as we expected. So now we use the colon or the range operator to set our vector, but keep in mind that's still the vector 1, 2, 3. So it's whatever that vector is. As I step through, x equals 1, 1 gets displayed. X equals 2, 2 gets displayed. X equals 3, 3 gets displayed, and you're done. Okay. I'm going to go again just to drive the point home. If I do 10 colon -2 colon 0, that becomes the vector. Let me put it down here. Let's go to command window. 10 colon -2 colon 0 gives us the vector 10, 8, 6, 4, 2, 0. So when we do this, x is going to equal the value 10, then 8, then 6, then 4, then 2, then 0. Okay, so let's execute this script. Oops, forgot to put my breakpoints in again. Execute the script, and let's go through it. Step through, x equals 10, display 10. Step through again, x equals 8, display 8. Step through again, x equals 6, display 6. Step again, x equals 4, display 4. Step through again, x equals 2, display 2. Step again, x equals 0, display 0. I've hit the end of the vector. I go on with my code, and I finish running the script. Okay? Now, as I did on the board, let's now give myself a little more room here in the command window, excuse me, in the editor. Let's now do this. A equals some vector, which I could define that vector anyway. I could also use linspace, but let's just say A equals some vector -99, 16, 0, 89, and 8. And then instead of defining the vector here, I just say x equals the variable which represents the vector. Okay. Now, as we've done a couple of times here, let's go through this. Set my breakpoints there, 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 and there. Execute the code. Window's clear, and we start off. So now, on the first line, on line 6, the value of A gets set. I didn't put the semicolon at the end here, so it didn't get suppressed. So A equals this. I now execute, go through the for loop. X equals the first value in A, which is -99. That value gets displayed down in the command window. Now x equals 16, which is the next value in A. And then that value gets displayed in the command window. I step again. X now equals the next value in A, which is 0. Now that gets displayed in the command window. X now equals the next value of A, which is 89. Step again. That gets displayed from the code block here. That gets displayed down in the command window. Step again. X now equals the next value in A, which is 8. Step again. Now that gets put down in the command window. Now I've finished going through A, so therefore I move on to the next block in my program. My script ends. Okay? So let's see that. Let me jostle a little bit here with the windows here. I'm actually going to come in and split my editor. Let me go back and not do it yet. I'm going to call here for a new function, a new script. All right, so I have a new script up here, and I'm going to actually split my editor window. So this is, once again, none of this has anything to do with for loop. I'm just trying to display this to you properly. This is the code we just ran on direct access, and now I'm going to do the same thing over here on the right hand side, but I'm going to do it using the indexing method. So let me do the clean slate stuff again here. So that we'll start off with clean workspace and a clean command window. And then I want to say the function we're going to do is counting, but this time we're going to use the indexing style. Okay? And I'm going to say variable A equals -99, 16, 0, 89, and 8. And then I'm going to say for x equals 1 colon the length of A. Once again, setting up the indexes to index in A and not call the variables direct. It's not call the values in A directly, but to index them. And so now instead of displaying X, I'm going to display A indexed at X. And then I'm going to end. Okay? That's supposed to be a semicolon there. Okay. All right. So it's going to ask me to save this when I run it. Let me go ahead and put my breakpoints in here. No, I haven't saved it yet, so I can't put breakpoints in there yet. So let me save this, and I'm going to call it indexing. Go lowercase indexing. Okay. All right, save that. Okay, now it's going to allow me to put my breakpoints in here, so I'll put my breakpoints in here, and it will clear it. So let's look at this one in action. So run it. Okay, so now I'm going to step through. We see A takes on the value of the vector A. We see that down here in the command window as well. Make the next step. X now equals 1. X does not equal negative 99. It equals 1 because we set it up to equal the indexing values so that we can index A properly. So I click through again, and you notice what gets displayed is the value of A indexed at X, which is A indexed in the first position, which is negative 99, and that's what gets displayed down here in the command window. Okay? Going through, X now equals 2, so we're going to index the second value, which is 16, and so that's what gets displayed. X now equals 3, so we display the third value, which is 0. X now equals 4, so we display the fourth value, which is 89. Step again, X now equals 5, so we display the fifth value, which is 8. And then now we've gone all the way through all the indexes for this vector here, the length of 1 colon the length of A. So now we're done with the loop, and so the little arrow says continue on, and we continue on, and our program, there's nothing else there, so our script ends. So this on the left is the direct access style, and on the right is the indexing style, both of which you need to become familiar with. Next, I'm going to do another example, the second example that I did on the board concerning given a vector and a number and using the if to build a result vector. This is our second example of implementing the for loop with both the direct access style and the indexing style. This particular script is going to take a vector and a scalar, which represents a cutoff value, and it's going to return or display a vector that of all the elements in the original vector that meet the cutoff requirement. So same thing I did in the board version of this. So let's get started. Once again, I want to put my clean slate stuff in here. Typing and nothing showing up. There we go. So I'm going to do clean slate here, and that's my clear all and my CLC. And then I'm going to do this. This is I just call this cutoff, for lack of a better term. And this is using the direct access style. Once again, stuff starting with the percentage, it's in green, are just comments to help us keep this organized as humans. So let's go back to A equals the vector negative 99, 16, 0, 99, 8. And then I'm going to say B, which is the cutoff value, equals 10. And let me suppress these with a semicolon. And then C is the empty vector we're going to build up as we do this through concatenation. Okay, so that's sort of our setup. Then let me come in here, for loop, and we're going to go down each value, each item in A, and we're going to test it against the cutoff value. And if it passed the test, we're going to concatenate it into our result vector, C. So that's the strategy here. So let's say for x equals A. So we're going to go down A in our loop here. Screen refresh. Sorry about that. Go down A in our loop here. If x, so x is going to be success value in A. So if x is greater than B, which is our cutoff value, then C is going to equal concatenation of C with the value x. And we'll end that and end our for loop as well. I'm going to give a little bit more room here, okay? All right, and so that should do it. Clean that up a little bit and put a semicolon there to suppress that. And then what we want to do at the end is we want to display what C is as our result at the end. Okay? All right, so I've already saved this file, so when I execute, let's put some breakpoints in here so we can see this, see what's going on. Really don't need the breakpoints on the end, but let's put them there anyhow. Add, that's good, we'll run this. Okay? So we run this, we come here at line 6, and A is our vector of doubles. And B is our scalar of double, type double. C becomes an empty vector of type double. So now I'm getting ready to start my for loop. So the first value x is negative 99. I do my test here. Is negative 99 greater than B? So what happens is I should skip from line 10. I should skip down here somewhere. So I skip, yeah, because I don't execute line 11. So I skip all the way down here to the end of the for loop. So I go to the end of the if, end of the for, and now I come back up and start my for loop. So nothing happened in this area here this time. This code block did not get executed because this was a false value. Okay? So now I go back up to the top. Now x equals 16. Well, 16 is greater than 10, so what we expect to see happen is C to begin to build here. So click that, and so I do enter inside the inside block that's inside my if statement because this value is true. And so when I do that, now you see over here, C now has the value of 16. So I end that and go back up to the top of my for loop. Now x equals the third value in A, which is 0. It doesn't pass this test here, so it jumps all the way down. Nothing happens. Nothing happens to the value of C, and I start my loop again. Now x equals 99, so that's going to pass this test here. That's going to be true. 99 is greater than 10, and so now I'm going to concatenate and add to the vector C. And so now I go into line 11. And now you see C now is equal 16 comma 99. So 99 got concatenated on the C. I go through again. Now x equals 8, which is the next value in vector A. And that did not pass the test here. 8 is not greater than B. or not greater than 10. And so I skip all this and go down to the bottom of the loop. I'm also finished with my vector, so I move on to the next value, to the next code block, because I'm finished with my for loop. And so now I display C, and you see now the vector C gets displayed here as 16 and 99. And then I'm done with this script, and so I'm done. So there you go. Let's now expand this a bit and see this side by side with the indexing implementation. So I'll split my window here and go to the indexing layer. Make myself a little bit more room so I can see. There you go. So I'll come here, do the clean slate stuff again. Clear all CLC. And then I'll do cutoff, and this is using indexing. Okay. Once again, A equals negative 99, 16, 0, 99, 8. Suppress with semicolon. B equals 10. Suppress with semicolon. C equals empty vector. Suppress with semicolon. 4. X equals 1 colon length of A. Once again, X is now the indexes of A, not the values in A. And so we go in here, if not X, but if A indexed at X is greater than B, C equals C concatenated not with X, but with A indexed at X. And I'll put a semicolon there on that. I need a little bit more room in my window here. There you go. Put a semicolon at the end of that. End, and then let's do display C. Okay. All right. So let's go through this one. Let's watch the value of X and how that goes. X should just go from 1 to 5 because there are 5 things in here. All right. So let's put in some breakpoints. Let's save it first. There we go. Let's put in some breakpoints. Okay. And we're going to run this. We're going to get cleared, which is good. Okay, so now we step through, anticipating A gets assigned the value of the vector, B gets assigned 10, C gets assigned empty. X now equals 1, which we anticipated because we're going from 1 to length of A, which in this case is 5. So X is going to traverse the vector 1, 2, 3, 4, 5. So if A indexed at X, which is the value 99, A indexed at the first value, which is negative 99. It does the test here that is not greater than B, so nothing happens. So you watch the arrow jump to line 13, skipping over the code block at line 11. We loop back through. Now X equals 2, so we'll be indexing 16. That should prove true here, so now C will get the value 16. We now jump down to the end, go to the top. Now X equals 3. We're indexing A at 3, which is the value 0. That will not be true on line 10, so we'll skip down to line 13 again. Now X equals 4. The value is A indexed at X, or A indexed at 4 is the value 99. That will be true here on line 10, so we will execute line 11, and so C gets 99 concatenated onto the end of it. We go through our loop again. X equals 5. A indexed at 5 is the value 8. That is not true on line 10, so therefore we skip all the way down to line 13. And now we do display C, which will display our value C here, which is the vector 1699. So there's an example of this same script being run with the indexing method as opposed to the direct access method. Next up, we're going to do the quality points example that we did on the board.